Let's fix this one. Cross out number 2 and number 4. Write down fix the note over here. In place of ln equal to log 10, you are going to have ln equal to log e. Now we're going to apply this one. Let me do number 4 one more time with you. I'm doing it over here. Pay attention, please. Everything stays the same except for when you substitute the values, you're going to substitute e in place of that. So here it's 2 ln 3x is equal to 8. Correct? What is my first step? What should I do? Divide by 2. Let's divide both sides with a 2. So it's going to be ln 3x is equal to 4. We good? In place of ln, we're going to take log e. Three x is equal to 4. So everything is gone. It's going to be, we're going to apply the formula now, which is log b base x equal to y, and we're going to apply all this b to the power y equal to x. So b is my e to the power y, which is 4, is going to be equal to 3x. Everything else stays the same. Nothing changes. The only thing changed is that in place of 10, you have e. That's it. Now we're going to put it in we can divide both sides with the 3 now. That's going to cancel it. X is going to be equal to whatever value we have over here. Now if you go to your calculator, turn up the top light please, so it cancels the glare. Top light. Yes, okay. Turn it on, clear everything. Second plus 712. Turn it on. Okay, now we're going to put this one in the calculator. E to the power 4 over 3. E is going to be over here. So second ln, that's going to bring your e. And on the top, I have the 4. Hit enter. Divided by 3. Hit enter again. 18.199, we can say 18.2, yeah. Question? We good? Go ahead, do no problems now. Keep your homework on the desk. I'm coming to check it, giving you 5 minutes. Go ahead, get started. We're going to work on the word problems today. This is the last thing that we're on this unit. Tomorrow we're going to have the review, and homework is due tomorrow. I'm going to upload the homework it should come to me by the end of second period. That's your period. You come in, bring it to me on third period. That's a late grade for you because that's not your period. Have a habit of doing it on time, your work. This is the period. I'm pretty sure it's the time then where you build all your habits, and this should be a habit that it comes to me. Okay, now look at this one over here. When the formula that we're going to use for all of them is the rate of change. It's going to be either growing or reducing. So it's going to be y equal to y naught e to the power rt. That's the formula, standard formula that we are going to use. Let me tell you. Depending on the situation, the variable may change. Like if you are dealing with the population, they're going to say this is going to be p equal to p naught, because from the population it's going to come p. So that's how we derive the formula, but that's the standard formula. Now this is a subscript, which is a 0 or not. That's how we say it. It means whatever is the initial value, that's the y naught or p naught or whatever that you have. Sometimes the formula will be already given for you. You are going to use that one. If it is given, take that formula, substitute everything in that one. If not given, then you are going to use the standard formula. Okay, but most of the word problems for this one, it will be given to you. Also, there will be half-life formulas. I'm pretty sure those who have the chemistry class and you calculate half-life a lot. So here it is. It's handy. Okay, it's all related. Math, physics, chemistry is all related. Whatever you are doing in the math class, you are going to apply either physics or chemistry. Whatever you are doing over there, you are going to bring it in your math class also. So we are related. Let's look at this one. Over here, please pay attention. The population P of a city founding in January 2009 is modeled by this equation. See over here, the equation is given for you. So we're not using this one, we're using already given equation. The city was founded January 2009. That's my initial time. That is when the city was founded. And this is the equation of that population of the city, where T is the time in years. The first question I'm asking you, if the population was 30,000 in 2014, now pay attention, the city was founded in 2009. So in 2014 is 30,000. It means that's the final value that we are dealing with. So it's going to be the P value over here. The final value is on the left side. And initial is over here with your T. Determine the growth rate. We're trying to find the R. Whenever I deal with any of the formulas, I always write down all the variables. Over here, I have the equation is given P of T is P actually. It's given T because you are dealing with according to the time. And equal to 10,000, 1, 2, 3, e to the power RT. Over here, P, then I have E is E, and R, and then T. These are my variables. Whatever I have, I'm going to write those values. Whatever I'm trying to find, I'm going to put a question mark over there so I can visually see what I'm going for. You don't have to follow this process. It's just my way of keeping track of everything. Okay, now over here, my P value which is given, which is 30,000. They're saying in 2014, my population becomes 30,000. 1, 2, 3. R, what is the R value? Say it again. What is the R value? Rate. What is given? We're trying to find. So let's put a question mark over here. I don't know it. I'm trying to find it. What will be my T value? Y5? Yeah, the city was founded in 2009 and we're calculating the population at 2014, so it's 5 years from there. So we're going to substitute everything over here. P is going to be equal to 10,000 e to the power RT, and so P value is 30,000. 1, 2, 3 is going to be equal to 10, 1, 2, 3 e to the power R. T value is 5. I just substituted all the values. Let me make it a little bigger for you. I just turned on this light so I can there is no glare in my calculator. Are we good? Okay. Now we're going to divide both sides with this 10,000 so I can clear everything. Your E has to be by itself. Remember, if you are dealing with the log has to be by itself and everything else goes on the other side. I'm doing the same thing over here. So let's divide both sides with the 10,000. So this cancels each other. On this side, if you divide it, what do you get? 3. Not 3,000. 3. I'm doing it over here. 3 is going to be equal to e to the power 5r. Short and cute. No. I need to find the R value. Now I need to get rid of the e somehow. Okay, so over here, if I take ln, so that to take on one side, that's going to cancel e. That's how we cancel. Like if I have a square, I take a square root to cancel the square. If I have a cube, I take a cube root to cancel it. It's the same thing. If you have e on one side, on the other side, if you take ln, e will be cancelled. It nullifies your e. So ln of 3 is going to be equal to 5r. This is how we cancel the e. It's exactly like taking the opposite of it. So if you have a plus on one side, you take a minus on the other side. So that's how we do it. If you have a square, you take a square root. Cube, you take a cube root. It's the same process. Are we good? Great. Okay. Now, we're going to divide both sides with a 5. That cancels. I'm going to have r is equal to this one. I can put it in the calculator. Pay attention to my calculator operations, please. If you are good with it, great. Otherwise, look at it. So turn it on. I'll have to clear my calculator before I do anything so it doesn't overcrowd my head. I'm putting this one, ln3. There are two ways. You can put the entire thing or you can do it separately. ln 3 over 5. So ln3, ln is over here. ln3, hit enter, divided by 5. That's my answer. 0.219, we can put 0.22. It's a percentage. Rate, so it's a percentage. Question. Are we good? Can I get a thumbs up, please? If everybody is good with it? Are we okay? How we got rid of the e? Perfect.
That part is confusing me a little bit.
So, what do you do if you are trying to find the e value? The formula for this one is mostly that ln e, it becomes a 1.
Okay.
The value of ln e is 1. So I'm technically taking ln on both sides, but since I have a e over here, so what I'm doing here is that ln3 is equal to ln e to the power 5r. Now this whole thing is 1, so that's gone. On this side I have ln3 is equal to 5r, because this is 1 times 5r.
Okay.
That's the step-by-step process. I just shortened it. Gave it. We good now?
Yes.
All right, no problems. Let's look at B. Please pay attention. Thank you. What will be the population be in 2019? All right. The same formula. Again, you are trying to find the final population. Okay. Again, the formula is given P equal to 10,000 e to the power RT. That's my formula given. Let's write down all the variables over here. So I have P, I have R, I have T. What is my R value? 0.22. We just found it. What is my T value? 10. Because it's been 10 years. The city was founded in 2009, and then this is 2019. So it's 10. What is my P value? We're trying to find it. Let's plug in everything in our formula. So it's going to be P is equal to 10,000, 1, 2, 3. E to the power, R value is 0.22. Times, I'm putting the times like a cross because there are decimal and so many different things. It's not X. It's just multiplication. And then 10. We good? We're going to put everything over here. Now pay attention to the calculator, please. Let's clear everything. Okay, I'm first finding this value over here. E to the power 0.22 times T. So E is over here. I'm going to press second ln. That's going to give you the E. Everybody with me?
Yes.
Then put 0.22 times 10, hit the enter, that's your value, and then multiply that with 10,000. It should be 90,250. Please don't put 90,250.13. It's human being.
You can zoom in.
Huh?
You can zoom in.
If I zoom in, then you won't be able to see my entire calculator.
That's what I want to see.
Good? All right. So the P is going to be 90,250. Are we good? Great. Let's do C. During what year does the initial population of the city reach 50,000? So what are we trying to find?
The year, the R, the N time.
The T value. So this is my equation. P is equal to 10,000, 1, 2, 3, e to the power RT. Let's write down the variable again. P R T. What is my P value now? 50,000. What is my R value? 0.22. And we're trying to find the T value. Let's substitute everything and try to find it. Okay. P is equal to 10,000 e to the power RT. I'm substituting all the value. P value is 50,000 is equal to 10,000 e to the power. R value is 0.22 times T. Is everybody with me? Are we good? Okay. We're going to divide both sides with 10,000. I have to make my variable alone on one side, the e or log or natural log, whatever you are dealing with. Let's divide both sides with 10,000. This cancels. On this side, I'm going to have 5 is equal to e to the power 0.22t. Now tell me, what should I do to get rid of this e? All right, we're going to take ln. So it's going to be ln of 5 is equal to 0.22t. Everybody with me so far? Okay, great. Now what do? Divide by 0.22. Put it in the calculator by yourself. I showed it already one time. And then check it with mine. I'm going to ask somebody for the value. From there. Quick, give me. What's the value? 7 point? Okay. So 7.3. That many years. But we have to give the year time. What year it is happening. So since it's 7, we started at 2009. So if you are adding 7 years to it, it's going to be 2016. But it's not 2016 only. It's 7.3 years. So it's the population is gonna reach in between from 2016 up to 2017, in between somewhere. We just don't know the exact date. So from 2016 to 2017, anywhere. Now it depends on your answer choices, how the answer choice is given for you in the test also. They can just give you 1 year, they can just give both the options. I don't know how they're deciding. Yes, ma'am.
We will always have a decimal.
Say it again.
We will always have like a decimal.
It doesn't necessarily have to be that way. It can come as a round number as well, depending on the what value you are. But since we are dealing with the ln function and e function, most of the time it's a decimal. It very rarely you are going to have a whole number. Okay. Let's look at number 2. Now pay attention. You did it before many times in your chemistry. Those who have chemistry this year. This is a half-life. You do it a lot when you if you are a chemist or a pharmacist or those type of people, you are doing the research on it. You are starting with something, and then after some point, it's becoming half. So that's called the half-life. It's important for the substances that gives you radiation, so you can know how long it's going to take to radiate and just automatically decrease to half-life. So this is what we are doing. The formula is already given for you for the half-life formula. Don't get confused when you see this T over here. The T means it's according to the time. That's it. It's just the N. So final N value, how much amount is left for you. N naught, the suffix means it's the initial value at 0 when the time just started, how much was it. So these are just the way of writing it. So the half-life of a radioactive isotope carbon-14, don't be so scared on that one. This is just the name of it. The half-life of a substance is 5730 years, 5,730 years. This is how long it's going to take to become half in any amount. If you have 2 grams of remaining, after 1,000 years, then what was the mass of the initial sample? We're trying to find how much amount we started with. So this is my equation. Let's write down all the variables over here because there are a lot of them. So N naught, this is how it's read, N naught, it means initial. And then we have T and we have T half. Now tell me, what is the T value over here? Time. Time is given for you. What is the time? In the question. Look at the question, not on the board.
5,730 years.
Sure? I'm asking about the T value. What is the T? Huh? 1,000 years, because that's the time that we are considering. What is T half? 5,730. That's the T half value. So that's the half-life. Okay. Now the 2 grams is remaining. So what will be that one? N is going to be 2 grams. And we're trying to find NO or N naught, initial value. So that's a question mark. So let's substitute everything over here. N is going to be N naught. 1/2 to the power T over T half. Let's substitute all the values. N value is 2. N naught value I'm trying to find. 1/2 to the power T value is 1,000 over 5730. Pay attention to the board for the value, please. So over here, we're trying to find this one. There are so many different ways to type it, whichever works best for you. I can type the entire thing together. I want to show you a trick that whenever you are dealing with the big numbers, you can copy it and bring it down. So what I do over here is that let's find this value first. 1,000 divided by 5730. That's the value. I'm not going to round it. If you start rounding it from the very beginning, your final answer will be so different from what we are expecting. Because see how big this decimal value is after decimal. So don't do that. Instead, this is 1/2 to the power this one. So what I can do, 1/2 is 0.5. So 0.5 to the power. I'm going to bring this value over here. So what you can do, take your cursor on the top highlight it, hit enter, it's going to bring it. Should I show it one more time? Hit enter. So that's my value. Let's do it one more time. So I need 0.5 to the power this value. So 0.5 to the power. I'm going to take my cursor over here. Highlight it. It's highlighted if I can show it. Once you highlight this one, if you hit enter, it's going to bring it on the top. Okay? Then hit enter, it's going to give you the value. I'm going to write it over here as 2 is equal to n naught, and this value is 0.886. I'm just writing it over here. I'm not going to round it when I'm calculating because it's going to give me a very different value otherwise. I'll do the same process again. 2 divided by this one. So I'm going to divide both sides with this number. Even though I'm writing only 0.886, but when you divide, use the entire number. Don't just chop it. Okay? So 2 divided by, again the same thing, let's highlight, hit enter, it's going to bring it down. Hit enter. This is 2.257, so we can say 2.26 grams. It's going to be equal to n naught. That's my initial value. So are we good? All right. If there is no question, you are going to work on the on the 2 problems on the back. Then we are going to go for the practice problem. Remember, homework packet is due tomorrow. That's everything that we did so far. And your practice is going to be, there are 12 problems over here, front and back. Question?
Miss Young, on the